Yes.
Can I
Share screen. Share screen.
where?
I don't know. Where's it? What's the share screen? Ah, here at the bottom, the green one. Correct. It's okay. I'll do it. I'll do it. I'll do it. You just talk. I'll share it. Okay. Talk.
Yeah, we can see your screen.
Excellent.
So this is just a moment. I want to share my screen.
Ah, okay. Yeah. Marcel needs to share his screen because he's going to demonstrate the AR. So we're just trying to figure out how to do it on his laptop.
Start the presentation. And our source DLT thing, our idea is from the developing countries drug management system. The supply chain is very pharmacy supply chain is very long and complex. Then we use the Hyperledger Fabric and the mobile phone. Skip. This is our demo. First, the user, for example, the pharmacy company and the delivery company and detailed pharmacy shop using our application and login by their each Hsm installed USB. And when our application detects the QR code, show up the 3D object and the explanation. And the user can read this each medicine's history viewing. And I show the real demo. This is our application. And the user login, or push the login, and insert the USB memory stick. The USB memory stick has one HSM, and read the USB, then enter the password, user enter, confirm the user, and the login status is show up. And the QR code printed on the medical package or just a board box. And the manufacturer company can show the history. Then for other users is login, and the other HSM USB memory stick is ready. And their one password, and the QR confirm the user. And the QR code is scanning. The delivery company can show up the explanation, and the delivery company staff can easily check what is the code box inside the medicine. Also, delivery company can read the history, the medicine history, and delivery company staff will log out, log in, read the shipping company staff. They are using their own USB memory stick, read the HSM and enter the password and confirm the ID. Shipping staff is scan the QR code, and they can read their histories and log out.
You have 1 minute left.
finally the like that.
Okay, we're going straight to the fabric demo. Can you see my screen?
Not yet. I can see your. You have 30 seconds.
I'm trying to show my screen. Okay, we got it. So we have a fabric network. It's all automated for the demo. So we're starting a demo. The network has 7 peers, 1 for each organization. So we should have 1 CouchDB, 1 peer for each organization, and then 1 CLI to control it, and 1 CA. So this is all being uploaded to GitHub. You can play it with it yourself. Yes.
So we go to the Q&A now. Yuri?
Yes, Amol, yes.
Yeah, so there's 5 minutes for Q&A.
I had a question. So this one tactical question on the HSM module that you showed, is that in your external? And what was the role it was playing there?
The role is to secure the wallet ID. So each organization, each representative or agent used it to identify themselves when they log into the network.
So for each representative from each organization will get such an HSM device. That is what you're saying?
Well, the user, the representative, the one who receives the package or delivers the package. Yes.
Okay. So for this prototype, is it a standard HSM device that you used, or is it just a USB device where you have kept the key?
Yeah, it's just a USB. For the demo purposes, we put the key on a USB.
Okay.
Otherwise, we'd have to buy a very expensive, real hardware wallet.
Hang on, I'm trying to bring up your documentation just to ask a question. So how much of this was built for this competition, and how much existed?
All of it. Nothing of this existed before. So I used the basic network in Fabric samples with 1 peer, 1 org, and then I multiplied it by 7. Got it all working. This chain code I wrote from scratch. I'm trying to get it running to show you. When we query the,
So actually, I think that helps me. I wanted to ask a follow-up, which is how have you structured the channels here between these 7?
So that's a very good point. So I'm just going to back to the presentation. I'm going to show you a picture of my channels. So this PDF is actually in the GitHub repo. So we have 3 channels and 7 organizations. So the idea was that the item channel controls the product info, and then we have some medical interactions at the end. So for example, the doctor writes a prescription, the patient gets the medicine. Now with most supply chains, there's no feedback loop. So let's say the patient gets an adverse reaction. All right, the patient tells the doctor, and then the doctor needs to report it to a regulator in a what we call a yellow card adverse event. This is quite serious, and it's a legal mechanism. Now we need to have patient privacy by collecting the patient data using private data collection. And then when a patient sees the doctor can be added to the patient channel, and it will be synchronized with the patient data. And then the doctor can use a cross-channel chain code to copy the data from the patient channel to the medical channel.
Yeah. So 2 quick questions here. Is this saying that the patient needs to run a node here?
No. We have the patient uses the mobile phone, the demonstration earlier. So it's a different version, but the patient can actually feedback into the system. So we can connect it with either a simple web app or even with the SMS. But the idea is that the patient writes data into a private data collection in the patient channel by him or herself. You only need one endorser, which is the patient himself, for private data.
Yeah. I mean, I have more questions, but I yield to some of the other jury members if they want to ask.
Yeah, hi, this is Ravi. So who are the parties who would be running the node here?
So the institutions like regulator and most of them, the shipping agent, pharmacy, and the doctor with a doctor's clinic, the pharmacy shop. So they have the financial incentives and the money to actually run it. But the patient would be a patient advocacy group or some other data management system. The patient doesn't actually manage any of this. It's a black box to them. It's just a web app on a mobile phone. So the idea is that we can integrate the medical features like prescriptions, like reporting, and so on.
Your time's up.
Okay. Thank you very much.
Thank you very much.
Enjoyed it. Everything's in the GitHub.
Okay. Appreciate
Thank you
it.
again.
Thanks a lot. And you can drop now.
Thank you.
Kamlesh, you can pause the recording. Give you a heads up when you have 1 minute left.
Sure. Hi, everyone. This is CD Reconciliate team. I have Prakash and Harshit with me. So this is basically about the application, what we have come up to reconcile the CDRs. This is the application, what it looks like. So here, when the operator logs in, he would be able to see his contract with an agreement. So this agreement would basically have a kind of a bonding agreement with a partner B. So you can see that there is a mapping from A to B. So A and B both being partner, and there is an agreement with the ID agreement 101. And you would see all the summarized version of the CDR here. And in the agreement, basically, you can see the rates and everything for the services being offered. And you click on any of the more information icon, you would see that particular CDR in detail. Then we have an option of listing all the CDRs in detail. And then we do also have a functionality of basically reconciling two CDRs from different operators and joining into a single CDR. So coming back to the infrastructure end. So here you can see, like, we basically have two instances of GCP, wherein we have Fabric set up, and we have employed 4 Kafka here with 3 orderers and CousDB. And similarly, like on GCP2, that's the second instance, we have CousDB and the peer node. So this is basically about the infrastructure. And then we have written our APIs on Node.js and our UI being on AngularJS. So right now, like, full functional UI is still not available because we are kind of facing a little bit issues in the integration side of it. But as like we can show that all the APIs, when we do it via Postman, it like we're able to basically add more contracts. So if we go and check in the CousDB, yeah, you can see one new contract getting created. So same way, like we have given the functionality of adding an agreement contract and basically batch load of CDR. So you can see like we have basically have quite huge number of CDRs in our system. Basically, these are all the test data we have come up with the for our use. So there are 271 CDRs right now in total. And we do have a chain code also written, which basically have a rule set which says that if A number and B number matches based on caller ID. So basically based on the call ID, it relates CDRs from two different operators and it generates a unified CDR. Prakash, you have anything to add on? So yeah, so as we depicted in our PPT, we kind of overcommitted ourselves before we started in it, and so we were able to do the loading of contracts, agreements, loading of CDRs. We were able to agree to the partners, and then like load of CDRs, and we were kind of able to get a chain code rule which says that okay, our unified CDR can be populated based on related CDRs from two different partners. So yeah, so that's about it. Yeah, Amol, I'm kind of done with my presentation.
Okay.
Here, Saurav, is you are reconciling these in bulk, and what is the common element you used? How do you reconcile a CDR between two things? Do they both use the same ID for it?
Yeah. So we have a field called call ID, which we are checking along with the A number and B number, that is source and destination number, and that we are basically fetching data from some relevant fields from both the CDRs and then formulating into a unified CDR. So we have a call ID basically that is kind of a deciding factor between the two CDRs.
And that is created by the originator, accepted. The same call ID exists in the other telecom operator.
Yeah, you're right. So A operator and B operator, both CDRs would have that call ID in common.
Right. And these are your design is for bulk reconciliation or transactional as the.
This is for the bulk reconciliation.
And so you upload a file into the contract, is it? Or
yeah, no. So we would basically upload a list of CDRs via file, basically a CSV format.
Okay.
So what amount of this data goes on chain?
Can you come again, please?
Yeah. So what amount of this data is stored on chain? I mean,
so right now, like we are storing as whole. So whatever
okay.
you're seeing on an Excel, since this we have considered it as a user-friendly Excel because CDRs, as we know, it's pretty complicated in nature. So this is right now as a kind of POC, we are uploading fully on chain.
So, but why do you need to store these on chain in bulk upload? Why can't you? All you need is resolution, right? Why do you need to store them?
How do you think this will scale? I mean, bulkly uploading all this data onto the chain.
Yeah, that's a good point. Yeah, truly speaking, like I know probably it might sound like an excuse, but we really started working on it since yesterday only. So yeah, whatever like it came to our mind and we implemented it.
So as a part of this hackathon, you have created this from scratch, right? Or any part you have created?
Yeah, everything is basically done in last 30 hours.
Okay, cool.
So I know like definitely it was probably fault from our end. If had we started earlier, we would have definitely done a lot better.
I don't think there is anybody saying anything is faulty or anything. I think the question is just in terms of your thinking, even if you have not implemented it. What we're trying to understand is how do you see this scaling if something like this goes in from your design perspective, right?
Yeah, I definitely get that. I definitely get that. That should be off chain only. The relevant part of it should be on chain.
So I think, let's say if you wanted to, tweak it, what pieces of information do you think you would be able to, you should be putting on chain?
Yeah, so it would be basically our contractual obligations, that is contract and agreement, and the unified CDR. So basically the center part of it, whatever you are seeing here, agreements, unified CDR, and basically invoice is something like which we haven't captured till now, but certainly agreements and unified CDR. Because our design says that basically operator A and operator B are generally what happens, they would reconcile from their own end, which basically are prone to a lot of malpractices and errors, right? So once the reconciliation is done, the unified CDR, what we say is basically treating it as a single source of truth, which is non-temperable, which cannot be altered, should be cryptographically secured. So that information definitely needs to be on chain. And then based on that, the invoicing should happen.
So technically this thing could still change. I mean, they should be real time then, right? Rather than bulk uploads. Because bulk uploads opens you up that between the time the call happened and the upload happens, anyway, things could not be.
Yeah, so idea behind the bulk upload is generally what happens is the CDRs would be like whatever we have read about in the blogs and all. CDRs are generally uploaded in a frame of 24 days or like there are some time frames. So we are kind of assuming that, okay, these would be uploaded every day, only once from both the parties. And then the reconciliation activity should happen only once, like at particular point of time in a day.
So what I'm getting at is, does it really solve the business problem? If you wait for 24 hours to upload a bulk CDR, you will still have, it's basically, they're two separate sets of data anyway. Will it solve the business problem of discrepancy elimination or?
Yeah, because your unified CDR is ultimately getting reconciled based on the data what you are getting from the individual CDRs from the operator. So you would have your own rules which would actually check based on the call ID that are there any discrepancies in terms of pricing, let's say call duration or any call status like short termination, like assuming that if the operator A is saying that, okay, it has been short terminated, but still you are seeing a CDR in operator B for the same call ID, definitely that means it is not possible, because A is saying that it is short terminated, but still you are seeing a record for the same call ID B. So those kind of issues can definitely be solved.
Saurabh, your time is up.
Okay.
Thank you very much.
Thank you.
Thanks a lot. Thanks, everyone. Bye.
Thank you.
Yeah, next in waiting, I will.
Kamlesh, you can pause the recording, please.
Yeah.
Shall we start? So,
one second. Yeah, Kamlesh is starting the recording. You can start now. Your time starts.
Okay. So I'm today joined by my team, Ravi and Shweta. So we all work together this week to bring the solution to life. So hi, everyone. A very good morning. Thanks for providing us the opportunity to participate in the HyperHack 2020 finals. For this hackathon, we have chosen to help solve the problem of counterfeiting of luxury goods. It is a major pain area for manufacturers, sellers, insurers, and financiers across the globe. It has some direct and indirect impacts for a brand, such as loss of revenue, damage to product and brand reputation, unwarranted product warranty and liability claims. It is pegged at $1.82 billion of revenue leakage this year for enterprises. But now blockchain presents a unique and genuine approach to tackle the problem of counterfeiting. We will showcase that luxury goods tracker, as we named it, is a viable solution for tackling counterfeiting. Let me give you a level 0 view of the solution. So we have 6 personas here. Manufacturers are moving goods to dealers, to retailers who are selling them to customers. We also have insurers and financiers into the mix, because for those insurers for insuring the luxury goods and financiers for financing them. So they are luxury goods and they definitely need financing at times. So we have ensured that each of these persona has lot to gain from this solution, including trust that they are all working on an authentic good. Every transaction here is getting recorded on a shared blockchain ledger powered by Hyperledger Fabric. In terms of nodes, while each of them bring their own node into the network, manufacturer will have to provision a node to be shared by its customers, or a high net worth individual may choose to bring their own node into the network. We will be creating channels for each different product from each different manufacturer. Thus, the ledger is only shared between the permission stakeholders who are actually interested in it and who are actually working on it. The main characteristics of this solution are cryptographically secured identity of the owners, association verification using zero knowledge proof, secured ownership transfer by using secret keys, even when it is and complete trail of ownership of goods for provenance. I hope I'm still connected, right? Hello?
Yes, you're connected.
Yes, sure. So now we started creating the solution this week, but we have a working solution that I will showcase you via a recorded demo. I'll skip some time. So here a manufacturer will connect to its node and is going to add a new asset, and an asset ID will be allocated to the asset, using which we can track it from the moment it leaves manufacturers and is trading hand between dealers and retailers. Here a manufacturer is looking at the details of a transaction or of an asset and has decided to move an article to a dealer. He chose the dealer and submitted the transaction, and the good is now handed over to dealer. Now asset ID is important here, as it is allowing us to track, as you can see, the asset ID over here. It is allowing us to track and associate the events. I'll skip the dealer moving it to retailer. So here, he moved it to retailer. So I'll just skip it. Now the retailer will now here the retailer logs in and is going to sell a good to customer. So he will look at his assets and he will choose to sell the good.
You have 1 minute left.
Okay, so now he's selling the good. He will put key in the necessary details, choose the financier and insurer. A set of keys is generated here, which are very important. All these details are recorded on blockchain except for the keys. As you can see over here, owner ID and owner email ID are crypto, and the phrase will allow us zero knowledge proof. Now an insurer will connect to its node and choose to void insurance for some reason, or probably a financier may choose to close a mortgage, so he can do that using this. And now the important aspect will be that customer can choose to log in. He will connect to manufacturer node, and he will he can perform all those actions and cannot be identified directly. He will key in the necessary details and the keys and the new customer details, and a new set of keys are generated, which allow for the new owner. And at last, let me showcase you zero knowledge proof using the verification phrase. So he'll put in key in the verification phrase without divulging his own details. He's done. He's verified that he owns it.
Thank you. You have now 5 minutes for the Q&A.
Sure. Thank you. So hope you like the demo. So we are open for questions.
Since you have mentioned, okay, please.
Sorry. Yeah. So this is Ravi. Quick question. How are you adding unique asset ID?
Okay, so unique asset ID. So we have a logic at the back end. Right now we are just using the Unix timestamp, but we will put in a unique ID using a Chase smart contract.
Okay, so in practical purpose, when the solution you think goes out, how would an asset have a unique ID that you can bring into your solution, physical world to digital world?
Yes. So for that, what we could do is there are, multiple ways. One, we could have a unique ID, like GUID, or otherwise, if for a human readable, we can have an incremental ID, but, both ways can work. So you can have a smart contract, which only, takes care of generating those unique IDs.
No, I think what I'm asking is, in a physical world, we are talking about the real world assets here, right? So an ID on a real.
Okay.
Yeah.
Okay. So for that, there could be two options. One, that, the manufacturer has a unique ID associated with its article. If yes, then, we could use that, probably a serial number. If not, then, we can generate it, and, we can have a digital twin, and, not be directly associated in that case. It will be only tracked by way of, having that serial ID embedded on blockchain, serial number embedded on blockchain with a unique ID for blockchain.
Can you tell me a little bit about the association verification using ZKB?
Yes. So for that, what we did is, we came up with a solution to use, random keywords as the keys, and so we are using the keyed hash, message authentication code, and we are using 512 bits of SHA, to generate hash using the key and an input phrase. So key and the input phrase both together combined, from a verification phrase. Let me just showcase you verification phrase here. Yeah. So here you can see the verification phrase. Yeah. So here you can see these phrases. These are generated by unique keys. For example, a customer will be given certain words, and those words, when combined, the key and the phrase will, generate this hash.
Sorry, so maybe I lost somewhere in between. This is for creating the identity of the wallet of the customer, or this is some association with the product?
So it is only there in the wallet to ensure that, if an owner wanted to divulge details, he could still do that without actually, divulging his own details. So what we did is, we provided him with a set of keys. One set of key will ensure, if shared, can prove that, he knows that key. He knows he has the input phrase and the key. That means he is associated with this. So if he provides it to someone, they can log in into the system, and they can verify it by generating a hash. And if both the hash matches, that means they are associated with it.
Okay. Okay. I don't know that that's really zero knowledge proofs, but okay.
I mean,
so the reason we said zero knowledge proof, because he could without divulging his own details, he could prove that he is associated with this article.
Okay.
So by ownership keys, do you actually mean that a customer could prove that he is actually owning the product? Is that what you're trying to say?
Yes, because owner name or email ID, all those things are not visible to anyone, and they are not shared. So, but if you have the ownership key and you provide the name and email ID, using the hashes, we can match and confirm that, okay, yes, he's the owner.
Fine, but how are you generating, creating these ownership keys? So unless and until you generate these keys from somewhere, a hardware wallet, I don't think this might be much secure, right? So if still you are creating these keys from a software perspective, these keys could go out of control from the customer, right? So someone else could claim the ownership if they want.
Yeah, if they get a hand on all these keys, then yes.
Mm-hmm.
Because, for example, while transferring, what we need is they provide the ownership key, they provide the transfer key and the transfer phrase, they provide the verify key and the verify phrase. So if someone is able to decode that, then yes.
Your time is up.
Yeah. Okay. Thank you. I hope I was able to answer the questions.
Yeah. Thank you very much. You can drop off now.
Yeah. Thank you. Just in case, in terms of code, the source code. So I have the Git repository, it in Git, but I would need at least one GitHub ID so that I can enable access on the same.
Sure.
Sure. Thank you. Thanks a lot for your time, everyone.
Yeah, thank you.
Thank you.
So there's 1 minute left.
Okay, sure.
Okay.
Yeah. So just to brief myself, that I'm Vandana Kamal, and I'll be presenting the solution for the CDR reconciliation issue. So for this solution, I have used the Hyperledger Fabric framework, and the chain code I'm going to write, I have written in Node.js, and CouchDB I have used as a database. Okay, so in this solution, so both the operators will be there, and they will have an endorser pair, committing pair, and anchor pair. Right now, I've used 2 pairs only. One pair will act as anchor pair and endorser pair both, and another will act as a committing pair for both the organizations, and they're connected with the private channel. Now, both the parties will send their CDR file to the channel where the smart contract will run. Now, these both operators are in different time zone, right? So I have ensured that when the CDR file is processed, first both the records are on the same time frame, so that the reconciliation can happen correctly. Okay, so it is going to be the batch processing. So now this is the scheduled CDR reconcile job, which will run once in a day, and it will create the summary report where the total number of CDRs that have been received will be listed. The incoming CDRs, they should match with the outgoing. If not, then that will be highlighted, and similarly the other case. Okay, so I'll show the demo of the project that I have created. So before that, first let me show you how the reconciliation looks like. So this is it's all in on the CLI right now, but we can enhance it to be shown on UI or maybe in some log file. So this is like just for 2nd of Feb, the reconciliation that had happened. So it is showing that okay, the CDRs matched, they are in equal, incoming and outgoing, everything is equal. For 225, we do see that there is some mismatch. The total count was 199, and for A, but for B, we only received 34, so that has been highlighted. And for 228, it's still 0. I'll run this again, just to ensure that yes, it is still 0. So this is 0. So I'm going to insert the records for them now. So these are the two CDR files that are having for both operator A and operator B. So this is how it looks like: call number, calling number, call number, the date and timestamp, duration, whether it is incoming or outgoing, and which switch has been used. Okay. So let me put this in the folder meant for it. So this is a serial for operator A. Now the processing will start, and tool our code has processed that file, and similarly for B. Sorry. Now if I'll go over here in the archive, I can see this is the for the 228. I can see that this file has been archived with the timestamp. Okay, now moving ahead. Sorry. So the servers that have already been started, so it has listed that okay, for operator A, the data is now it is showing on the console.log that there are around 250 odd records in both the files. So this is for operator A, and this is for operator B. Okay. For operator B, it is still running. Yeah. Yeah. Just I'm almost done. I'm just waiting for the result to come. Since I'm using one order only, and right now, and the records for first organization are getting listed, so that's why I'm getting it is a bit delayed for operator B.
How many records are there?
There are around 250 odd records in the file. Let me show you.
Your time is up.
So, okay, so but yes, just let me run this once to see if.
We can start the Q&A and this can run in the background.
Yes, yeah, sure. So there were 270.
5 minutes for Q&A.
Yeah.
Hi, this is Ravi. So what would you do in order to make your solution more scalable?
So for hi Ravi, good morning. So for to make the solution more scalable, one thing is that if there are n number of organizations, and since the data is not going to be shared between them, means right, it is just will be one to one only. So we can have a different channels created for interaction between the different clients, between different operators to share their data and for the reconciliation process.
Hey, how big was this team that built this? Was it just
Sorry,
you?
sorry, your voice is not audible.
Is this built just by one person, you, or there was a team that built this?
No, no, I did this alone only.
Okay. And so the smart contract here is basically matching the CDRs and putting final
Yes.
list out, right?
Yes.
Hi, I'm Prasanna here.
Yeah, 100%.
So just wanted to understand a few of the aspects like as a single-handedly you have created this architecture, development and every other aspect
Yeah.
quite applicable. But what's your next step? Like how do you want to really, you want to just create it and just leave it for this hackathon, or would you like to build on another story on top of this?
No, I'll definitely like to build further on it. Means right now it is just at the, CDR level. But when the reconciliation happens, it is at the billing level as well, right? Rating are decided, and then further it is checked whether whatever amount we are checking is the same or not, right? So those invoices that we share in the end, we can have that reconciliation on the day basis itself. So enhancing the smart contract to have the rating information as well, and then applying the rating charges and we're seeing whether it is coming same or not, and if we can have some threshold which is actually agreeable, that okay, this much amount is there, and if this much mismatch is coming, that is fine, maybe of you say $5 or $10, something like that. So all those things can be implemented to smart contract, and we can check whether it is working fine or not. And then again means we can fetch the data from here at the for at the number level as well, the calling number or at the call number as well. So all those things can be enhanced means through this smart contract. So yes, I'm definitely looking forward to actually work on that aspect.
So I have gone through the architecture diagram, okay, so which you have submitted. So I wanted to understand, this is tightly coupled with the CouchDB or any other database can be used, any other data storage system?
So for that, we means we can use the another storage system. Right now, basically Hyperledger give level DB and CouchDB, and since it requires the querying as well, so that's why I've used CouchDB. But right now, other parties just like Oracle are also coming up, right, to have the Hyperledger interact with their databases. So it's going forward, we can change the the settings of the network, and we can have other databases as well interact with the smart contract.
And this code is available, right now on your GitHub.
Yes, it is available. If you are facing any issues while while accessing it, just let me know. I'll see means if there are any permissions issue or something. But yes, it is available on GitHub.
You have just over 30 seconds left.
So last quick one from my side. In order to again make the solution more scalable, what do you think in terms of storage of data on-chain versus off-chain? What data goes on-chain?
On-chain, it basically depends till what level of till what level you want to reconcile the data. If you just want to reconcile the CDR data, that whether they are same or not, then we can just have if the count is same or not, then we can just have the number of calling records and chord records to be stored over there. Means we don't need to have those duration thing. The total duration thing that is not required, and we can just store the count over there. And if we want to do enhance more intensive reconciliation based on billing as well, then accordingly the data need to be placed on chain.
Your time's up.
Okay, just let me see if I can this one.
Your time is up.
Yeah, just 5 seconds. Let this run. I just want to show you the records are matching, which was coming over there. That's it. Yep. So, thank you.
All right. Thank you very much.
Thank you. So I can stop sharing the screen.
Yes, you can stop sharing and you can drop off now.
Thank you.
One second. All right. So you ready to start?
Yes, yes.
Okay. So your time starts now.
Yeah. Yeah. Good morning, everyone. I am Harika from TCS Research, along with my colleague Padmaja. I would like to take this opportunity to talk about our proposal called Ledger. In this talk, first I'll cover the problem statement, key features of our solution, and explain the solution in detail. Coming to the problem statement, in the existing systems, dispute settlement is a long and time-taking process, which is blocking the revenue of the operators for months to years. To address this problem, we came up with a solution based on blockchain for storing call records for faster settlement. Our solution also preserves privacy of individual call records. This slide summarizes the unique features of our system. We provide verifiable proof for the call settlements using cryptographic tools. As already mentioned, we achieve faster reconciliation through blockchain and also bring out data privacy and data transparency. Now I'll quickly walk you through the solution details. The initial step is the setup phase. In this phase, each operator creates a set of private and public key pairs and has a private data collection with the other collaborator. Operator sensitive data such as call details are stored on private data collection, whereas the proof details, hashes, are stored on the blockchain. After the setup phase is done, the reconciliation is done for the time interval L. L may be a day or a week. As you can see, the XIKL value is the aggregated call duration for time interval L. Similarly, for operator 2, it is YIKL. For this aggregated call duration, authenticators are computed and each operator submits a transaction proposal with the call record, its hashes, and its authenticators. After this step is done, we do the billing settlement for a D-day cycle. At the end of the D-day cycle, a proof is computed for that cycle using these aggregated call durations and authenticators. These proofs are stored on the blockchain, which are accessible to all, and call records are stored privately on the private data collection. As a next step, we construct a Merkle tree on each peer using the XIKL and YIKL as a pair of leaves. This nomenclature helps the auditors in case of disputes. After the proof generation is done, we go with the verification steps. Verifier retrieves the required information from the blockchain and runs the verification algorithm. If the verification succeeds, the settlement step is done. And if it fails, the data, with the data residing with the auditor, a root hash is computed and to see which record is mismatching. This completes solution details. Now Padmaja will walk you through the video, the demo video.
Yeah, initially we created a POC network of our call ledger with 4 operators, where all 4 operators will share common public database, and between the participating operators like operator 1 and operator 2, we are creating a private data collections which we are going to store call durations in the separate database. So for each of the participating operators, we have created 4 different private data collections. Harika, you can start the video.
Yeah, I already started the video.
Okay. And we have deployed, and Harika, I am at 12th second.
Okay.
Sorry guys, I am not able to share my screen. So.
Yeah, now I am at 12 second. Yeah.
Okay. Now before submitting the aggregated call durations, I am just querying the blockchain. Now we are submitting aggregated call duration for a time interval of 7 days. In the POC, we are doing the settlement process for 7 days time interval. Now you can see 7 aggregated call durations for operator 1.
All right, so folks, your time is up. We can go to the Q&A session.
Okay.
Yeah, sure.
Okay, we'll have 5 minutes.
So this is Ravi. A quick one. You mentioned aspects of data privacy in here. What are the data privacy aspects you have implemented?
Yeah. So the data privacy comes in. So each operator has aggregated call duration, right? So these call durations should not be shared with others. So these durations are stored on a private data collections which are accessible only to the operators that are involved in the consensus process. So other details such as the authenticators are stored publicly because they can't retrieve anything from the authenticators. They are just proofs that the aggregated call durations are computed correctly.
And in proof verification also, we are validating the proof given by the operators without revealing any operator sensitive call information, like the call duration. Without revealing that operator sensitive information, we are trying to validate the proof given by a particular operator.
I mean, could you please explain about how you are showing that proof verification to an? I mean, how does an auditor does the proof verification?
Individual operators will generate the proof, and they will send that. They will.
So proof as in what is that proof that you are creating?
Proof is the computed call duration. The aggregated call durations are correct. So if operator 1 sends some outgoing call durations to operator 2, so we create a proof that the computed durations are correct in the proof generation steps.
Since you have mentioned about Merkle tree,
this is the DLS signature scheme that you talked about?
Yes.
Yeah.
We are sending aggregated call duration for a cycle of D days to the BLS, to the pairing-based crypto library, and we are generating the proof. We are storing this proof into the blockchain, and auditor, while verifying the proof, auditor will reveal that, auditor will
retrieve the proof from the blockchain and verifies the. So the data is revealed only in case of if the verification fails, the auditor will be able to see the data. Since he has to see where the mismatch happened, then only they will be able to see the data. Otherwise, no data is revealed for the outside parties.
So I have a question here on if you're using private data collection and the two operators involved in a particular set of call records are anyway having those call records, why do you need this BLS scheme?
Between
we use
the operators.
BLS.
Yeah, continue.
Yeah, Padmasha, continue.
Yeah, between the operators, we are, for a particular transaction, the participating operators will share the data. We are not hiding data between the participating operators. We just want to hide data from the other operators and from the auditor.
Yeah,
but other operators needs, so auditor or a verifier needs to know that the computations are done correctly. So we bring in the BLS here.
1 minute left.
Okay.
Yeah.
And so another question is, are these BLS scheme generations and proof verification, is this happening in smart contract or is it happening off chain? These functions are available and implemented in the smart contract?
Yeah, actually, we have created a wrapper, like client server architecture. We had PBC. We are making use of Stanford PBC library with all these functionalities, and from the chain code, we are calling this server, PBC server, which is running on the host, or we can run this PBC server on some central repository also. As of now, we are running this PBC server inside each operator node. From the chain code, the call will go to the PBC server. From there, it will generate the proofs and verify the proofs.
Okay, your time is up.
Have you used some kind of Oracleized service to make this off-chain calls from chain code?
Sorry? Hello?
No, we haven't used any Oracleized service as such.
So if you have 5 nodes, then 5 chain codes instances would make 5 different calls, right? To the same service.
Yeah, from each node, the chain code call will go to the PBC server. Yeah.
Okay.
Okay, your time is up.
In our setup, the server is running on the host itself. Peer itself.
Okay, all right. Thank you very much, Harika.
Thank you so much.
Your time is up. You can stop sharing now.
Yeah. Okay.
All right. Let me know when you're ready.
Sure. Okay. Yeah, I'm ready.
All right. So your time starts now. You have 5 minutes.
Yeah. So our idea is basically an ecosystem of applications. It starts with a web browser. We are supposed to make into a module that can be deployed in the backend as well. So what this module, we're calling it self-sovereign crypto for now. What it basically does it, once you install it on your browser, it generates a public key pair and public-private key pair on your account. It creates a password also and gives you that password, which is not stored on the ecosystem anywhere. So this is something that the user needs to remember. In future, we can have like mnemonics and other things, enhancements. Basically, now what this, sorry, one second. What this extension basically will do is it will see now once it was installed, it gives me the this key, which is going to be my password for this ecosystem, complete ecosystem, one password that I have to remember, and it's not stored anywhere. Now after this, what happens, any request that we make, for example, we go to facebook.com, what this extension will do is, this extension intercepts the request to facebook.com. It redirects the request to a blockchain ecosystem. In this scenario right now, we just have an application to show. We do have a blockchain ecosystem of our own, but we haven't implemented this, connected this extension with the existing blockchain ecosystem. What will do is this will redirect the request to blockchain ecosystem, where this requests are written down, and any application, for example, if it's Facebook will need to create a application on this backend on this blockchain, a chain code, which will map these API calls. For example, if I just did facebook.com, it should do an authentication call, and that's what Facebook has to take care of in the chain code. Now, why we are doing this is because every request, once it gets logged on to a public system, and the requested body, the secret is the requested body is encrypted. Now, any application that needs access to that requested body needs to request the user for that data. For example, if I have to use Facebook, I can go use Facebook. Facebook has a chain code. It will keep redirecting, but everything that I do will be encrypted using a secret password that if I share with Facebook, Facebook will have access. If I share it with Google, Google will also have access. So it's like a public ledger of all the activity that I'm doing on the internet. Now, this is not this is not bound by any sort of identity for me. So what we have done, we have gone ahead and done is that we have created a separate platform, which is actually running. It's called Identity on a skills chain platform. I'll show you in a different browser. So this connection part is something that I wasn't able to finish. I've been like sick for last 3 days. But yeah, the basic idea is this only. Now, based on incentives, I can ask user to map their public key, which is shown here in this QR code, to an actual account, maybe to an identity. In this case, it's Gaurav Singh, which is me, and it's related to that public key. My email addresses, my social accounts. Now, this is an application that does a lot more than...
1 minute left.
That does a lot more. Now about requests, I can show you like any request that is generated on the platform or any data that is encrypted is stored on IPFS and can only be viewed after using that password. For example, I uploaded my degree, for example, onto the network. It was stored on the public blockchain, but it can be stored encrypted using this password, and I can be, in this case for testing, I had uploaded my PAN card, but yeah, the idea is that. Yeah, so that's pretty much it. Yeah, I can take questions now.
So Gaurav, I have a fundamental question. So
yeah, please.
The W3C identity standard for decentralized identity, right?
Yeah.
Work the way this thing that you work, the app that you built. Why would you not go and adhere to the standard as opposed to building your own?
No, so we are building see, the idea of self-sovereign identity is that you can do anything on the network without the network knowing who exactly you are. You declare your identity. Now, what I'm showing you here, this identity application, this is something else. It's something built on top of that ecosystem. It will reward user to create identity, like connect their real world identity to this crypto identity. This is an application that's built using the extension. But the idea of the extension in general is to log all your transactions and give permission to apps, and that's in your control because it's encrypted by your password and only you can allow that access.
Yes, I understood that. I'm saying to achieve this exact same thing, there is a standard that has emerged on how to actually build around self-sovereign identity.
We've been building this for like 3 years now, actually. I've been playing around with this idea. I want it to be essentially very simple. Now, this crypto extension that I've built can also be used for very simple authentication using digital signatures. Like a login request is sent to a backend. It generates a 256-bit string, which the front-end application, the extension, will sign and give it back to the backend, which gives the session token. And in this way, a secured communication can have after that, like continue after that. So there's no use of username, passwords anywhere on any applications ever again.
Okay.
So Gaurav, could you tell me what is the business model that you are trying to achieve here?
So business model, we haven't thought about, to be honest. For example, different applications can have different business models. In this case, in case of identity, for example, it's direct, like 1500 per user because it's a verification thing. For the blockchain itself, we have 5% transaction fees. Like, for example, this is an application that we make. For example, Facebook registers with us. Then for every transaction fees, like payment wise, where, for example, user opens up his data to, let's say, Google, a Facebook data to Google, for which he's rewarded. Of that reward, 5% comes to the ecosystem.
So since you have mentioned you were working behind this for past 3 years, so have you heard something about a tool called SQRL, SQRL, Secure Quick Reliable Login?
Yeah.
So I think they are also doing the same thing like what you have said, right? I mean, the digital signature authentication and all.
Yeah. I wasn't aware about that. I'll check it out for sure. Actually, SQRL, yeah, I wasn't aware.
I mean, if someone wants to verify something, so how are you going to implement that part? I mean, what are you going to share to that person? You
Verify
shared about
as
some password, right?
All right, I'll tell you. For example, so the things in this picture are essentially a user, an application, correct, and our blockchain ecosystem. So in this case, we'll consider, for example, in your case, suppose an application maybe wants my data or an individual person wants my data. Both the things are possible, right?
Exactly. So since you have shown a certificate over there, so if company HR wants to view your certificate, so how are you going to share it to that person?
So for that, what we essentially do is we have something called access requests. If you can see here, a person can send access requests or receive access requests. This is a request protocol that we have integrated in the background. What it does, it basically, so each item has a unique key which encrypts it. And that unique key is only shared with every user each time a request is made. Now, incentives have to be provided so that this does not leak out of the system. And of course, that's where game theory comes into play. And that's
So
where
each time, I mean, when you create a unique key for sharing, so what actually you might be doing is encrypting the document with your unique key and sharing that document with the other party.
Now then I have to share it with you. Then I just encrypt that unique key with
where are you going to keep this encrypted data?
It's on the blockchain.
in IPFS, you are saying?
Yeah.
So this would be very redundant, right? So if you want to share it to so many people, every time you'll be creating new passwords, encrypting it again and again, putting it into the blockchain, putting it onto the IPFS. So for a single document, if you want to share it with 1,000 persons, you might be creating 1,000 passwords and.
So we are exploring the cryptographic part. There's a cryptographic research, of course, involved in that, and there is one algorithm. I forgot the name, for God's sake, how I don't know, but in which keys can be shared with 1,000 users also with much ease. And we have made our modules, crypto modules, very modular, so it can be replaced later. Of course, we have to think about that. Is one issue. What you pointed out, that's a big issue, and we are thinking about it.
Your time is up. Amol, can I just take 10 seconds to make a point? So Gaurav, just a quick note on this. So 3 years ago, we did similar projects. We took a similar approach. It's long. A lot of things have happened since 3 years. There is a W3C decentralized ID standard. If it needs to be a commercial solution, I would advise you 2 things. Follow the standards. Don't roll your own crypto. Your own signatures and signing schemes and stuff like that. Follow the standard protocol and build your value-add application on this. The way this is structured today is not going to fly because you are very divergent from the standard, and all the other jury questions have opened up some of the challenges that you have, including the last jury member who was asking the question.
Sure.
Just look at the redesign of this.
All right.
Okay.
All right.
Very much.
Thank you so much.
You can stop sharing and you can drop off.
All right. You guys have a good day.
Thanks. You too.
Started.
All right. So you have 5 minutes now. Get started, please.
Am I audible clearly?
Yes.
So our topic is telecom call detail record reconciliation. I am Akhil and he's Arnab, and we are blockchain developers from Call Analytics in Bangalore. So introducing the topic first of all. So the telecom networks generally, when they wish to connect with each other, so they interconnect, and let's say the Vodafone from India and Airtel from USA wish to connect. So they'll use the interconnect services to connect to each other, and the network operators charge each other for connecting via these services. So the problem is that at the end of a, let's say, defined cycle, let's say monthly or after 15 days or something, invoices are generated for all these call detail records, and these are reconciled to generate the invoices. But the problem is that there may be mismatches or something happening, and maybe there are some missing call detail records or some mistakes, sometimes honest mistakes and sometimes malicious, and this process becomes cumbersome because of this.
And because it is an old process that's ongoing, it is really difficult to manage disputes or problems or mismatch from the records. So each of them independently keep record, and there's a huge dispute, and that's where blockchain comes into picture.
So, and the database that these telecom companies use are mostly centralized and not encrypted, and possible manipulation is there, and this is where the problem comes. So what we are looking at is a blockchain-based solution which can streamline and interconnect this billing and make it instant, reliable data access over there. And since blockchain ledger becomes a single source of truth, and we can use smart contract to automate agreements, we feel that this solution could have a pretty high potential. And now talking about the blockchain platform, the organizations involved in this are mainly the ones in which data privacy is required. And when two organizations interact, the data is like highly confidential and it cannot be revealed at any price. So we are looking at Hyperledger Fabric, and it is because it's a private platform, and there's no need for miners also, so no high computation power required. And we have the orderer that handles the consensus algorithms, and also no cryptocurrency required. And so we feel that it's a best platform that we could use. So this is our business architecture in brief. We have the user signing in, and we have made a web application with the front end and the back end. And the first part is the data adapters, which comes in the back end, and the input which the user makes. It is like aligned with our input requirements and put into the back end. Then there's the configure reconciliation part, in which a user can configure if the reconciliation needs to happen, let's say every 15 days or every hour or every month or something. Then based on the defined and configured reconciliation, the automated invoices would be generated. And that's the part where automated invoices module comes into picture. And a user can also configure alert. Let's say if in the reconciliation something mismatched, so all the mismatches would be like sent on email or could be sent to our SMS. One can configure the alerts as required. The next part is the agreement module. So whenever two organizations agree on some rate, let's say they agree on charging a particular amount for a particular interval, so we also put that into the main chain in the Fabric network, so that later one can verify on the chain and be sure that what the agreement was done previously. And the last part is what we have is something called the reputation module. And in that, what happens is that using AI techniques, what we're trying to find out is which organization has low reputation or high reputation based on the mismatches happening.
Yeah, I'll add on to that. So when there's a lot of dispute going on throughout over time, so AI can recommend, like AI can predict which party is more likely to be the root cause of dispute or something.
Folks, you have 30 seconds.
Yeah. So we'll show you a demo application we have created on blockchain. Backend is using blockchain, and we have already opened it. So this way we are saving the call records. Okay, it's the normal thing. And let's say there's one company, Reliance Jio. It has partnered with other two companies, and we can see the records, the record that is saved from our end, agreement with them, and the billing. So in the billing, we will have the record sent by, let's say, Vodafone. They will send the record that they have saved, and we will match them, and we will bill them, and there will be a list of disputed records. Okay, and reputation is under progress. Okay, yeah.
So we'll go into the Q&A now.
Sure.
5 minutes.
Okay, from the architecture that you have shown, so how many modules have you built from that? So we can see the data adapters, the configuration.
Data adapter is yet to be built. Configured automated invoice and the alerts, that part is done. Agreements module, we have created it, but I think we need to do a little bit more of a domain study and make it extensive.
So right now the agreement is only about what cost the organizations agree between themselves.
Okay, so but how are you going to onboard this data onto the platform? I mean, the CDR data.
Say some organization comes in and it says that the data is to be stored in a particular format. We'll build data adapters so that it complies with what we have, and in that way the data gets inputted.
So the data that is normally getting from some sort of sensors that every call record. So we will integrate it the same way.
And we wish to do it real time so that the organization can get access to it as immediately as possible, because that is something which is not there currently.
Right now we have mocked it in a Python script, like real time set of data that we wanted. Did he answer?
Yes, yes. Other judges you can ask.
what are your parameters used in order to reconcile the two files and find out the discrepancies?
Yes, so do the reconciliation, what we are doing is, let's say there's organization called Geo and organization named Airtel existing on a particular channel. So this data would be private from the other organizations. Now, when the two organizations both have their data on the channel. So if we wish to reconcile, what Geo will do is it will take the call data record identity, let's say CDR1, and find the one uploaded by the other organization, let's say Vodafone. So we'll fetch CDR1 for both organizations, and which would be there on the channel uploaded by the two organizations, and then compare all the particular attributes in it, and if a particular CDR is missing, or
I will add something specific to it. So what we are doing is we are mapping same ID to both of the records, as it's on blockchain. We can do that, and once we have the same record, we'll match the phone numbers and the duration to. If they have the exact same thing, we will add them to the billing part. If there is any mismatch, we'll add them to the dispute section. How to handle dispute is another study that we need.
And the ones which match automatically invoice.
Yeah.
And what data goes on chain and what is stored off chain?
Yeah.
So a hash of the record will go on chain. Everything will go on chain. And based on the agreement, like everything is happening on chain, and we are just creating this application to have a visual version of it.
Right now, agreements and CDR data records are on chain, and the reputation which we were wishing to work on.
So what is the significance of that off-chain DB shown in your architecture?
I'm saying reputation, which we were like aiming to work on. Let's say a mismatch happened, and in the invoices which we store, let's say PDFs, they are being stored off chain. Other than that, all the CDRs and the agreements are being stored on the network.
You have 1 minute.
Okay. Anything else you'd like to ask quick?
Yeah, so one question here. So GDPR, I think, treats phone numbers as PII, right? So if you're putting this phone numbers as part of CDR on,
yeah, that's what, like we
that'd be a problem.
In the application, we have demonstrated it with the stars, but ultimately we will be hashing it out so that it can be verified with the off-chain DB, but the hash will be present on the
hash
DB.
would be compared, yes.
Yeah, so
So actually, so not to give you a hard time, but I think a hash that is consistently mapping to a same number, right, without a sort in it, is also considered PII in GDPR.
There's a concept of salt, like we add salt and it cannot be mapped to the same number. It varies every time.
Yes, I know. So I'm saying it's a bit of a challenge. So then how do you put this in the contract and not violate GDPR? Because if you salt it, you can't match it. If you don't salt it, then it's as good according to GDPR as the phone number itself.
I think we'll need to work on it.
Yeah. This is something we did not know about the compliances. So yeah.
Okay. So the other solution is if we don't want to, we can keep the phone number, some data off chain, and then remaining on the chain, like the ID and duration and these things, and combine the calling number and make a simple hash. That hash we can map it if we have both the number, but no one can map it like calling number, call number. We will use both of the data hash with a salt. So that I don't think will be against GDPR, but we've checked on it.
Okay.
Yeah.
All right. Thank you very much.
So, any feedback that we can expect?
Yeah, what we can improve on or something like that.
So that
feedback, particularly good attempt. I think you need to keep thinking about some of the issues around performance and privacy, but others, good work.
Thank you.
Thank you.
Okay, thank you. You can stop sharing now and you can drop off.
Okay, it was nice talking.
Kamlesh, you can stop the recording.
Yeah.
Right. We'll start with our architecture overview. And so if you look at the problem, it's on the CDR reconciliation. We have two carriers, carrier A and B. That's how we wanted to start the problem with. And we have used Hyperledger Fabric. So I think this should be shared with the jury team as well. So with that being said, I'm now going to go over the architecture that's been presented already. So I'll just walk you through like how our solution is unique. The way we differentiate ourselves is with oracles. So if you look at the problem statement, it said like nearly 80,000 and 10,000 CDRs are being shared between operators. It's not feasible for you to load all the data into blockchain, right? So what we did is like we are using oracles. So oracles is something that is going to fetch whatever is required for smart contract and then write instead of loading all the assets to blockchain. Right, so that's how we differentiate ourselves from other participants, and that's important thing which I want to bring upon. And now let me go over the POC stack that we have built. Okay, so we have used Angular for DApp, and we have used EC2 instance Fabric, and we have been mocking up with databases and API using MyJSON. So I just want to highlight few of these steps. So all the features that we are going to show, all got started after we got mail that we got selected. Okay? So nothing was there before. That's the first thing. And application is fully functional, meaning we have provided plug and play. So I believe whatever code we have written, right, should be plug and play. And we have open sourced it. This is the link where you could go and find it. And yeah, these number 4 and 5 I have already covered it. And just to give a bit of EC2 instance, we are writing it in. I mean, we are using it T2 small instance for demo purpose, and we have not distributed the Fabric with different arcs using K8, but we are just using one EC2 instance, and both organization operator A, operator B, and regulator runs an EC2 instance. And our SDK API and DApp also runs in the same EC2 instance. Okay. With that being said, let me take you through the application. Okay, this is the application that you are seeing. Okay, there you go. So if you look at this, this is something that got loaded today. On the left is usage minute. The CDR format we shared is been listed here. If you go and look what are all the attributes that we are using in the dashboard, can be referred from this slide. Okay, we are using call number, the subscriber and receiver call number and the call number, and then start time, end time, call type, and then charge and the call results. So these are all the important attributes of CDR. When we investigated, we thought to load only these things into the demo steps. So these are all are operated by smart contracts. Okay, if you look at this, we have something called as a bad job. So if you look at the architecture, this is I'm doing it from operator A. Okay, so operator A has got to share his operator B exchange API. So if you look at this is the real data that is residing here. Okay, so what I'm going to do is I'm going to use oracles. Okay, I'm going to use oracles to fetch all this data, dump it here, and then let smart contract process it. So this is the bad job. Now if you look, I'm going to invoke something. Okay, all the data that you see here, right, you see in the other tab will be pulled and validated by smart contract. So I have started my job. You'll get an alert soon. Okay, yeah. So if you look at this, Put the disputes. Sorry? Put the disputes. Yeah. If you look at this, the values will be getting reflected. And if you look at this, right, it will say you like how the oraclize pulled up the data. For instance, it says this particular.
Is up.
Sorry.
Your time is up.
Okay.
Okay, you can probably keep doing this in the background while we start the Q&A.
Okay.
So you'll have 5 minutes for Q&A.
Yeah, this is something, to verify that you called it from the oraclize. All the CDR disputes.
A question here, when you said initially this was the difference between your team and others, your voice was a bit muffled, so I lost you there. The main difference you were highlighting was you're hooking the oraclize API and pulling the data into the smart contract, or was it something else?
Yes, exactly. That's the point. We are not loading all the data. We only let smart contract to pull the data and then validate however it wants to do.
I didn't understand. What do you mean not loading all the data?
Okay. For instance, you could load all the 80,000 records, right, inside the system.
Yeah.
Why should we do it? Because we just want to highlight only the disputed CDR. We don't want to leverage.
What records will you load? Only the ones that have a dispute?
Yes, but we will process all the record, all the CDR record, and we will only load into the blockchain that has only CDR disputes.
And so who runs that service at the other end of that oraclize call that is processing all the records and then deciding which are the disputed ones?
Exactly. Oraclize brings up the data, and then our smart contracts go through the logic.
I think you didn't get my question. I asked who runs that service at the other end of that API call of oraclize. You said oraclize runs oraclize. Who's running it? Is it operator A, B, or U?
Yeah, it's operator B. For instance, if it's operator A, operator A got to call is operator B exchange API. Did I answer?
So operator A calls operator B's API and gets what operator B thinks are the disputes. And how does that help you?
No. See, operator A operator. I think I'll let you know.
The point here is both operator A and B are going to expose their data to each other, so that in that billing system they are going to come up with the disputes and things. But in between, they are going to bring in the oraclize. So what it is going to do is every day they are going to anyway transfer the CDRs, but in operator A system and operator B's billing system, they are going to expose all the CDRs. This is going to be pulled by oraclize. So when they pull the data size and the number of records and everything, we will create a checksum. That is one validation, and each record will be validated with the smart contract that both the operator A and operator B are accepted. And whenever we find a dispute, that's going to be known set, and then there can be manual issues also. So everything is going to be copied into our database system, the blockchain database system. This is what is going to happen when both the people are going to share their APIs. So this oraclize is going to help us by reducing the number of data sets that we are going to load into blockchain.
But how is this dispute identified from the CDR data? So, I mean, if operator...
Yeah, so we have certain rules, probably like when one of the circuit or tower goes down, right? These are all the filtering criteria we have listed. This is just to give mock. Probably if you have call number, right? This is the person who is trying to call the other number. Now, if this is not empty and you are being charged, which is not a valid scenario, right? We just flag that immediately, in the real time. For instance, if you look this right, you have the subscriber number who is calling, but you don't have the receiver. But you have been put a charge, which is a valid dispute scenario. We are just marking things here.
You have about 45 seconds left.
No, but what you are saying is the operator B will consume the Oracle service, right? In order to fetch the disputed data from operator A. Is that what you're saying?
Exactly, correct. Both got exchanged, yeah, right.
But I mean, how are you going to identify that dispute without loading the data onto the, I mean, you have to keep it somewhere to identify the dispute, right?
No, that the smart contract does it for you, right?
Yeah, if the smart contracts want to do that, I mean, where are you going to keep this data? I mean,
Yeah, this data is going into the blockchain. Okay, all the disputed data is going into blockchain. Only the non-disputed record are not going to blockchain. All the disputed data goes into blockchain.
Your time is up.
Just one point. Validating the disputed data happens whenever they trigger this. Like each record will be checked across the smart contract, and if there is a problem, it's going to be checked into the database.
Okay. Thank you very much. You can stop sharing now, and you can drop off.
Thank you.